Hello and welcome everyone. We still talking about the OSPF and we should talk about the point 6, the LSA type 3. We already talked about the LSA type 1, LSA type 2. Okay, now it's time to talk about LSA type 3. And as usual, the new approach in this course is when you take something, when you just study the technology, you should study the optimization of this specific and particular technology. Because in the reality, you need every specific topic to be connected together to get your end. Imagine that you are in a scenario, in the situation, in a case, and you've been asked to configure OSPF in like DMVPN network, and you need to just optimize the LSA type 1 behavior, and you should just reduce the database. You got the point? You need to study the technology with the optimization of this specific technology. You need to link the technology together. You need to just take the benefits from all the tools around you to get the full picture clear to you. So, regarding the topic 6, the LSA type 3. So, as we mentioned already earlier in the beginning of this task, in the beginning of this section, the OSPF, when you design the OSPF, when you implement the OSPF is based on the hierarchical design. What's hierarchical design? Based on the area itself. You have the area 0, it's the backbone area, and every area else is connected to area 0, right? So that's why it's a hierarchical design. So area 0 in the middle, and specifically at this point, when we talk about areas, OSPF areas, and the backbone area and non-backbone area, there is also a specific terminology for the OSPF speaking routers. Like, like if we just bought all the 3 routers here in area 0. Okay, so what is this router that it will link area 0 with area maybe 783? We call this router what, Ammar? We call it, this is the ABR, area border router. So what a nice name, what a fancy name. But what is the specific functions, what is the specific jobs that the ABR does for us, does for the OSPF network? We'll see what's the ABR functions and what's the ABR's jobs and what's the ABRs can do for us in a couple. So router 4 is the ABR. So why we call it ABR? Because at least, that's a term, that's a condition, at least one of the OSPF interfaces, one of the OSPF enabled interfaces in the area 0. This is a condition. So when we call a router an ABR router, when one of its interfaces link to area 0 and the other link to another area, not area 0, not a backbone area. So in this situation, we have router 4 act as a ABR, we have router 5 act as a ABR, and we have router 6 act as a ABR. Okay, guys. So right now, we're going to make sure, because from the previous implementation to this topology, all the routers bought it on area 0. So in this session, we need to separate the areas. We need to just take the yellow area here and in this specific routers bought at area 0, and the one on the left hand side will put an area like it's just 10, and the right hand side will put an area 20 or 50 or whatever. Okay guys, so after this we're going to discuss what exactly the LSA type 3 in the OSPF terminology. The LSA type 3, when you imagine that you are live in an area, specific area, which is area 20 here as example. Area 0 should contains what? Contains LSA type 1, LSA type 2, and these specific LSAs should stay within the area, not going beyond the area. Okay? But these are routes. At the end, these are routes, these are prefixes. So we need to just inform the other areas about these routes, about these LSAs. So first you have a condition, you have this term don't send, or the LSA type 1 will stay there, will stay inside the area. LSA type 2 will the same, right? So we need to take the LSA type 1, convert it to some other LSAs, and send it to another areas. Whether be area 0 or another area, we'll see that. Okay guys? So this is the ABR's jobs here to do that. We'll take all the LSA type 1 and convert it to generate another LSA type. We'll call it LSA type 3 or summary route. Okay? So when the route came to me from another area, what we can call this route inside the OSPF routing table? We call it inter-area route. So when we just say this name, inter-area route, there is an ABR involved in the process. There is an ABR who generated this inter-area routes as a form of LSA type 3. Okay? So we will see that, and after this we will see how we optimize the behavior. And how we can optimize the behavior? Same as when we talked about LSA type 1, LSA type 2. How we reduce, leave the route, leave the LSA in the database, or take it out. But when we talk about LSAs filter, or LSAs taking out or reducing this kind of specific LSAs, it's a different story. It's not like just LSA type 1 or type 2. So we'll see this in a couple. We just putting the terminology, explaining all the stuff before we do the actual configuration here in the routers. So what we should do now is configuring the routers here in area 20. This is in area 10. This is in area 0. Okay, we can just put these 3 routers here in area 50 or 90 or whatever. We'll just decide later. Okay, from taking a look on router 2, we can see that all the loopbacks of all the routers in the topology of the autonomous system 65001 listed here 1 to 12. But the thing is, while we're seeing the O letter here, this is indicating what, Ammar? This is intra-area route. What? What is intra-area route? It's just the exact opposite of inter-area route. So intra, this means that this route, it's just received from the same area that I existed in, right? We'll just need to change the behavior, moving from intra area to inter area route. Doing this will be uh, going to just make router 5 involved in the process, router 4 involved in the process, router 6 involved in the process. Converting to inter area route, meaning that you're going to make a hierarchical design. You're just going to put some areas out there linked to area 0. So basically, now it's a croquis drawing here. So we have area 0 here, area 500, area 400. Okay, so doing what here? Doing on router 5, we'll just set the configuration. Router 4 will set the configuration. Router 6 will set the configuration. So let's just do this. Take router 5. So when you change the area, you can do it under the process level or the interface level. We'll see. So show run section OSPF. As you can see here, under the OSPF, we having all the networks that start with 10.1.0.0 in area 0. So I'm going to delete this line here. Basically, the relation to the other neighbors will be down. Router OSPF 1. No. Basically, we'll say router ID 1111 5. And under the interface 0102, I will say interface range E01 to 2 IBOSBF 1 area 0. So the relation will be back. Now we have the relation back with 4 6 2. Okay, no problem. But 2 and 12, we will just do the following. Interface range 0 0 and 1 0. IBOSBF 1 area 500. So you will see that there is the OSPF is complaining here. Hey man, what is that? I'm receiving an invalid packet. There is a mismatch area ID. Why is that? Because you're receiving in the hello message from router 2 and router 12, 2 and 12 saying, hey 5, hey whatever in the other side, I am in area 0. But router 5 is not in area 0 anymore. It's in area 500, right? So we need to change the behavior to make the relation back in the right track. Actually, we'll put all the interfaces in area 500. But specifically, I'm not going to do the same thing router 5. Router 5, I went to under the interface level and say, hey, this is area 0, this is area 500, blah, blah, blah. And router 2, router 11, router 12, this is called the internal router. What's internal router? Internal routers means that all of its interfaces inside the same area. So you have a variety of options here. You can go under the interface level or under the process level to say, hey, all the interfaces, all the network in the same area. It's no problem. But in the ABR, it's a different story. You have to be specific. So let's just go to router 2 and see what is the actual configuration. The issue runs section OSPF, no router OSPF 1, and router OSPF 1 area 500 and 500. Cool. Router 11, the same thing. No router OSPF, or just we can see that how to process expedite. Come on. The same thing. Back on track. So router 2 now, let's check router 2. Are you with me, Ammar?
Yes.
So what change do we have here in the routing table? Can you see that? IA, 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 IA. Except the 11 and the 12 because they are in the same area as mine. 500. So what's IA? It's inter area route. This is actually the LSA type 3. Generated by whom? Generated by router 5. Because this is the ABR who's linking my area, my switch area to area 0. Right, Ammar? Let's check the database and see actually who's originating this LSA. Okay. Should I be OSPF database summary? Let's just take any LSA, This is okay. This is router 3 here. Link state ID, which is the loopback for router 3. The advertising router. Look at this. This is what I need to see here. Who's generating this LSA? Who's advertising this LSA to me? The ABR. Why? Because the ABR links the two areas together. Because the ABR here has all the LSA type 1 from area 0. Right? So I think you might have a question. And I hear your thoughts, man. So what if router 4 is the EBR here in area 400 and just transferring all the LSA type 1 and advertise it to LSA type 3 to the area 0. Router 5 here going to advertise the LSA type 3 coming from the area 400. How? Let's clear this out and see it in the real. Let's configure router 4 and see how the router 5 will see the actual route coming from another area. So is the router 5 going to regenerate the LSA type 3 coming from another area, or what? This is what we're going to see. Let's configure 4 in area 0 and then stop the video and put all the rest of discussion in another video, because I don't need the video to just to be too long. So actually let's stop here. See you next, guys.